we have a region bounded by the four curves here. Y equal to 5 divided by 1 plus x squared. Y equal to 0. So x-axis, x equal to 0. This is y-axis. And x equal to 8. We rotate this region bounded by the four curves about x equal to 8. And we obtain a solid. We need to compute the volume of that solid. So let's look at the first curve. Y equal to 5 divided by 1 plus x squared. So this is a rational function. We have the first remark that this function is defined, is well defined on the whole domain defined on R. So for any values for minus infinity to plus infinity, the function is well defined. The denominator is always non-zero. And we see that values of x, for all real number x squared is always greater than or equal to 0. This makes 1 plus x squared the denominator at least 1 for all values of x. So this means y divided by this is at most 5. 5 divided by 1 plus x squared less than equal to 5 divided by 1 less than equal to 5. So 5 is the maximum values for this function. So the maximum point is when x equal to 0. So the equality happens when x equal to 0. 0, 5 is the maximum point. The second remark is that this function is even. So it is to say that f of x equal to f of minus x for all values of x, or f is even. So this means the function is symmetric. So this is because y equal to 5 plus x squared equal to, so this is f of x. This is the same as f of minus x, which is 5 divided by 1 plus minus x squared. So these two are the same. This is because x squared is even. So x squared equal to minus x squared. This function is even. This means that this is symmetric. Above y-axis. So we can just need to draw or graph half of that and then reflect about the y-axis. We get the graph of the whole function. What else we can remark about this function? When x tends to infinity, plus or minus infinity, this one tends to plus infinity. So the denominator tends to plus infinity. This means that 5 divided by plus infinity, this one tends to 0 when x tends to infinity. So y equal to 5 divided by x squared tends to 0 when x tends to plus infinity. And it also tends to 0 when x tends to minus infinity. Because it is symmetric, we see from above. So what happens is that it has a maximum at 0, 5. It is symmetric about y-axis, and it tends to 0 when x tends to infinity. So we graph the function. X, y. Here's 5. So the function would look like this. So the function look like this: y equal to 5 divided by 1 plus x squared. And we have 3 other lines: y equal to 0, x equal to 0, and x equal to 8. Y equal to 0 is the x-axis. Y equal to 0. X equal to 0 is the y-axis. We have x equal to 8. So this point is x equal to 8, y equal to 5 divided by 1 plus x squared. And we have the vertical line x equal to 8. X equal to 8. The region bounded by the four curves we just draw is this region. Now we need to revolve this region above the axis x equal to 8. So we revolve this above this axis. And then we have the hollow part here. So the whole solid look like this. And this part is empty. So the solid we often would look like this. So here's the solid we have. And there's a hollow part here. We need to compute the volume of this solid. So let's see which methods we would use. We can do methods of dishwasher methods by slicing perpendicular to the axis of revolution. So x equal to 8 here. So we would have two regions we need to compute. The first one is the above region here, above this line. So we use the washer methods for this part to compute this solid, the volume of this solid. So for the dishwasher test, washer, we slide perpendicular to the axis of revolution for the part above this point. So we need to compute the volume of this part first, and then we compute the volume for this part revolving this region about x equal to 8 later, because we use a different function here. For the part above here, this part above this line, since we slide perpendicular to the axis of revolution, the axis of revolution x equal to 8 is parallel to the y-axis. We have a partition of this segment. The partition of this segment gives us each piece has a length dy. When delta y tends to 0, we have dy. So this piece here has length dy. Delta y tend to 0. We have dy is the thickness of the cross section, and the cross section is a washer. The outer circle comes from this green curve. The inner circle comes from this red curve. By revolving this piece about x equal to 8, we obtain this washer. So this is the washer we have. The outer circle corresponds to the green curve. The inner circle corresponds to the red curve. So the inner circle corresponds to the red curve. So this gives us inner radius r in, and the outer radius r r. For the outer radius, it's easy because the outer radius is easier because it's just the distance from the axis of revolution to the green curve, which is 8. But for inner radius, the inner radius is the distance from the red curve to the axis of revolution. So in our case, for example, is this length. This point x, y. The inner radius is the distance from this point to the axis of revolution. So this is 8 minus x. This length gives us the inner radius r in. R in is the distance from this axis to this point. So it's equal to 8 minus x. We need to compute this in terms of y because we are doing dy. We are given this red curve is a function y as a function of x. Now we need to solve x in terms of y. So we need to find x in terms of y. So find x as a function of y. So in this case, this is y equal to 5 divided by 1 plus x squared. This is 1 plus x squared is 5 divided by y. 5 divided by y minus 1, and x is the square root 5 divided by y minus 1. For this part, when x is positive, so now the function x in terms of y can be complicated. It's 8 minus square root of 5 divided by y minus 1. For outer radius, this is this distance. So the distance from the green curve, which is the y-axis to the axis of revolution, x equal to 8. So we know that the outer radius is always 8. This is the distance from 0 to 8. R outer equal to 8. So with that, we know the inner radius and outer radius to compute the volume using washer method, but only for this part. Only for this part. For the second part, we compute it separately because now this is cylinder. The cylinder with the base, this circle. That's how we do it. And the height is this. Now we need to compute the coordinates of this point and we can find the height of this cylinder. And we can find the volume of this cylinder. That's how we set up if we use a dishwasher method, which is quite complicated. If we encounter this case where we need to find x as a function in terms of y, where the function can be complicated, we should use the shell methods, and here's how we do it. Now we compute the volume using the shell method. For the shell method, we slide parallel to the axis of revolution. So in our case, parallel to x equal to 8 or parallel to the y-axis. So each slide look like this. By slicing parallel to the y-axis or x equal to 8 here, we create a partition of this segment 0, 8, which is the segment on the x-axis. Then we have the partition with delta x. When delta x tends to 0, we have dx. So the integral would be in terms of x. By revolving this strip about x equal to 8, we obtain a cylindrical shelf. It looks like this. By revolving this strip above x equal to 8, this is a shell we have. Now we need to compute the volume of each shelf, and then we take a sum of all the infinitely many thin shells. We get the volume of the whole solid obtained by revolving this region about x equal to 8. So this shell, if we cut it along the height, we get a rectangular. So this is a rectangular we obtain by cutting the shell along the height. Here's the height. The height of the shell is this distance. So now look at this point. It says this is x, and this point lies on the curve y equal to 5 divided by 1 plus x squared. Here's the corresponding y. The height of the shelf is this length, which is the y coordinates, which is this value. So the height is given as phi divided by 1 plus x squared. The thickness of the shell is delta x. The width of the shell is delta x or dx if delta x tends to 0. And then we have the length of this shell, which is the circumference of this circle. The circumference of this circle. So this circle is a circle with radius 8 minus x. So here is the radius of the circle. The radius is the distance from this point to the axis of revolution, which is the distance from this point x to the point 8 here. So x0 to 80 or xy to 8y. So this radius is 8 minus x. So the length, this length is the circumference of the circle of radius 8 minus x. So the circumference of this circle is 2 pi times radius, which is 2 pi 8 minus x. So we found all the data to compute the volume of this cylindrical shell. So the volume of a thin shell is given as the length times the width times the height, which is 2 pi 8 minus x delta x times the height. That is the volume of one thin shell. Now we take the sum of the volume of this thin shell, infinitely many thin shells, we get the volume of the whole solid. So the volume of the whole solid would now be the integral in terms of x, where x runs from 0 to 8. The volume of the solid is the integral where x runs from 0 to 8 of all these thin shell. And now we have dx tends to 0. Here delta x tends to 0, we have dx 2 pi 8 minus x phi divided by 1 plus x squared. So now we have 2 pi times phi, so we have 10 pi out there. Inside we have 0 to 8, 8 minus x, 1 divided by 1 plus x squared dx. And by doing computation, we get the volume of the solid.